Rises in the east, sets in the west. Yet two planets spin the opposite direction. For Venus and Uranus, the sun rises in the west and sets in the east. Uranus not only has a retrograde spin, it rolls on its side like a bowling ball. At Neptune, the icy moon Triton orbits backwards, opposite from the direction of Neptune's spin. Do these planets spin backwards because they were rocked by titanic collisions in the past?
So we see evidence in the architecture of the solar system for not only collisions like Earth's moon, the fact that Venus is rotating in the wrong direction, Uranus is on its side, for all these things are attributed to collisions. We also see in the asteroid belt and in the Kuiper belt, the outer asteroid belt, if you like, we see that the orbits of these things look like they've been disturbed.
Closer to home, our own Earth has an inexplicable 23.5-degree tilt. Its spin axis is radically misaligned from its magnetic pole. And our moon is comparatively large for a planet our size. Now, a new theory may be able to explain many of these oddities. It is called the Brand-Tach hypothesis. It is called the Brand-Tach hypothesis. 4.5 to 5 billion years ago, a gas giant planet arose inside a primordial disk of gas and dust.
Jupiter didn't just form where it is, but formed and then moved inward towards the sun.
As it spirals toward the sun, Jupiter herds asteroids and rubble. As it spirals toward the sun, Jupiter herds asteroids and
Jupiter's
rubble.
natural tendency is to drift in slowly through this debris field that it's traveling around.
Jupiter herds asteroids and rubble. Natural tendency is to drift in. The inner solar system is also thick with gas and dust. The birth of our planetary system is well underway. Numerous worlds are born in this region, including the Earth. Primordial skies are ruled by chaos. Jupiter's approach destabilizes these planets. Their orbits decay into wildly swinging ellipses. Some are tossed out. Others fall into the sun. Their numbers are unknowable. These are ghost worlds from a bygone age.
Jupiter just causes all heck to break out in the solar system, and all that debris in the outer solar system gets flung inward towards the inner solar system.
And it was a busy time in the very early solar system, and things were colliding with each other all the time.
And then it stopped. Jupiter's invasion of the inner solar system is mysteriously halted. The planet makes a turn, or, in sailors' parlance, a grand tack. Lurking behind Jupiter is a second gas giant, Saturn.
So as Jupiter was migrating inward, Saturn was following it and growing. And as Saturn was growing, it came to have a size that it had a gravitational impact on Jupiter, which became more important than the gravitational interaction between the gaseous disk and Jupiter. They reverse direction. And in a sense, you can think of Saturn and Jupiter feeding off one another and moving back out.
Gravity tugs each passing planet. This transfers orbital energy from one world to another.
All you have to do is exert a very subtle little periodic force at the right time, and you can have amazing changes in the motion of the object you're pushing on.
Once enough energy has been transferred, the planets synchronize their orbits. They are said to be in a resonance. For planets, resonances are achieved and maintained through the mutual push and pull of gravity through the fabric of space. They're a key factor in the continuing evolution of our solar system. This effect can be duplicated in the lab.
We have 10 metronomes here set up on a swinging platform. They have little weights on pendulums here, but they've all been set at the same frequency. And I'm going to try to start them as best I can, completely out of phase, randomly. So their oscillation is going to transfer energy by the swinging of this plastic sheet to the other metronomes that are out of phase to get into phase with the majority. It's inevitable that there's going to be some majority group which starts out swinging more or less together, and they are eventually going to win out. Just doing this as randomly as I can. Aha, maybe in this corner I see 4 that are pretty closely synced. Yes, now it's more like 5, 6. Now you have one that's almost completely out of phase. Every time the majority hits a beat, it's going to give a little impulse, a little push to the platform, and that push is transferred to the metronome that's not in sync. Because the platform, you can actually see this platform vibrating back and forth in sync with the majority of these metronomes. Working on this one. So pretty close to resonance right now.
As the metronomes achieve resonance, it's important to notice how the platform shakes.
Now, it doesn't have to just be the force that's being transmitted by the plastic platform. It could be a force at a great distance, for example, the force of gravity. Just these small, little, seemingly insignificant pushes building up over multiple cycles can have dramatic energy transfer. That is how planets do it.
Like the metronomes, the two gas giants form a resonance.
We don't know exactly how long that took, but we have some fiducial marks for timing in the solar system formation, and that means that the Grand Tack had to have occurred relatively quickly, talking hundreds of thousands of years, perhaps to a million years.
The two planets retreat until they reach their current positions. The sequence of planets as we find them today is based on Jupiter and Saturn's orbits. The planets eventually achieve a sequencing that many students learn through a mnemonic, such as, "My very educated mother just served us 9 pizzas."
Was there a time when the mnemonic was scrambled? Seems very likely the answer is yes. Not to mention a lot of additional letters were probably in there as well.
Jupiter's menace of the inner solar system is finally over.
If Saturn had not formed at the right time in the sufficient size, Jupiter would have continued migrating in, throwing out objects, unfortunate objects in the inner solar system, and ending up very close to the sun where it would stay. Yes, the Earth would be gone. Or the Earth would have had a terrifying encounter with Jupiter and would have been had its orbit changed dramatically to gosh knows what.
There is mounting evidence that Earth had a terrifying visitor. Not Jupiter, but another world. Theia.
Theia was essentially another proto-Earth, where there were a number of these objects flying around. And Theia took time to grow just like the Earth did. They probably had rather similar histories. And for one reason or another, the orbit of Theia was perturbed such that it collided with the Earth.
Theia was this planetary body that was roughly the size of Mars, and through this collision, a lot of particles were ejected, probably completely destroyed. We don't really know how much of Theia was preserved.
Earth is rocked off its axis. Its surface liquefied. Chunks of Earth's mantle are shoved into space. As a planetary body, Theia ceases to exist. Its remains are absorbed by the Earth and intermingled with the debris field. A new planetary body is formed, the Moon. Further evidence is found in rock samples from the Apollo moon landings.
This is a sample from the Moon. You can see it. This was collected by the Apollo 15 missions.
Moon rocks contain isotopes identical to those found on Earth. When the Moon arose, it is first covered with a magma ocean.
People imagine the lunar magma ocean to be like this magmatic chamber I am describing, but at the surface and covering a whole planet. I see it as this ocean, like the Pacific, but this has to be like completely magmatic, orange, and like probably like fluxing around and probably moving.
Conditions in the lunar magma are as hellish as we can imagine. But a microscopic treasure forms in the magma: crystal zircons. These are the same gemstones used in jewelry, but the zircons in the Apollo moon rocks yield a different treasure.
So those zircon are very important because we know they crystallize in this lunar magma ocean. We know roughly when they crystallize in the lunar magma ocean. So they are one of these old pieces of the moon that we are looking for, one of these old pieces that we can use to date the origin of the moon.
Zircons not only give the age of the moon, they set a specific date for the collision.
The age of the moon is 4.51 billion years old.
4.51 billion years ago, Theia becomes part of Earth and forms the moon. But the story is not over. Space probes measure the moon slipping 3.8 centimeters further away each year. One day, the moon will break free. When that day comes, there will be no more tides, no more romantic moonlit nights. Could planetary orbits be inherently unstable? Could the chaos of planetary migration return? Haute-Provence Observatory, France. It's here that a discovery from a faraway star gives one of the biggest revelations about our own solar system. The story begins when Swiss astronomers Didier Queloz and Michel Mayor noticed something unusual about a star 50 light-years away in the constellation of Pegasus. Everything about this star is ordinary: a main sequence midlife yellow dwarf, just like our sun, but with one strange difference. The star at Pegasus 51 is rocking back and forth. It's a weird anomaly astronomers have never seen before. They check their instruments. Everything is working, including their new spectrograph, a device that splits the starlight from Pegasus into rainbow colors. Hidden inside the colors are patterns of lines. By tracking the day-to-day movement of these lines, astronomers make a startling discovery. Pegasus 51 has a planet. But no one has ever seen a world like this. It's half the mass of Jupiter, yet it's extremely close to its star, 9 times closer than Mercury is to the Sun. The planet at 51 Pegasus must be inside the corona, broiling in temperatures over 1,000,000 degrees Fahrenheit. Soon, another planet is found around another star, and then another, and another. Astronomers have now confirmed over 3,700 exoplanets beyond our solar system. Nearly all of them are Jupiter-class planets, grazing their host star. They're a new, previously unknown type, called hot Jupiters. They're so numerous, hot Jupiters challenge theories about the origins of planetary systems.
It's very difficult to make a planet close to the star because there isn't enough mass to build a giant planet very close to the star, and there's gravitational frustrations for trying to build a planet very close to the star.
Astronomy is shaken with a new revelation. Planets do not stay put where they're born. When they're big enough, they migrate. It's a process called planetary migration. And yet, our own solar system has no hot Jupiter. Astronomers realize the Jupiter in our solar system was once on the move as well, but its migration was halted by a resonance with Saturn. Pegasus 51 shows where a planet lands